This video about the pyramid is designed to introduce you to the idea of the pyramid and to show you how to find lateral and surface areas of the pyramid. Let's take a look first at exactly what a pyramid is. It's a polyhedron, meaning that it's made up of polygons, whose faces are in the shape of triangles and only has one base. So if we look at the picture here, what we've got going on is we've got these triangular lateral faces and one single base. Now the faces all come together at a point at the top of the pyramid, and that point where they all come together is called the vertex. Like prisms, all pyramids are going to be named for the shape of the base. So in this case, the base is in the shape of a pentagon. It would be a pentagonal pyramid. In the instance where the base was in the shape of a square, it would be a square pyramid. The altitude, or the height, of our pyramid is going to be the distance from our vertex to the very center of the polygon which makes up the base. Now a regular pyramid is going to be a pyramid whose base is a regular polygon. And in the case where the base is a regular polygon, the lateral faces will all be congruent isosceles triangles. So in other words, each one of these triangles that makes up the lateral faces are going to be congruent to each other and also isosceles. The other vocabulary term that you need to familiarize yourself with respect to the pyramid is the slant height. The slant height is the distance from the vertex up at the top down to the base measured down the side of the pyramid. And really, this picture does a very nice job illustrating the difference between altitude or height and slant height. The altitude, or the height of the pyramid, is going to be the distance from the vertex down to the center of that polygon, whereas the slant height is going to be the distance from that vertex right down the side of that pyramid to the center of the line segment which makes up the base of the pyramid. All right, lateral area. Like all of the other three-dimensional figures that we've studied, lateral area is going to be the total area of all of the lateral faces and is not going to include the area of the base. And likewise, surface area does include the area of the base. However, for the pyramid, there's only one base, not two like all of the other geometric figures that we've studied thus far. All right, so let's go and take a look at and see how this would work in an example. They're asking us to find both the lateral and surface areas of this regular pyramid whose base edge measures 300 feet and whose slant height is 354 feet. So if I think about what this means in terms of my picture, we've got a base edge here whose measures 300 feet. So this is going to be the base edge. It's a regular pyramid, meaning that all of the four sides that make up the bases or the base edges of this pyramid are all going to be 300 feet. Slant height, remember, is going to be the distance from this vertex down the side of the pyramid. So the slant height is 354 feet. So lateral area. In order to compute lateral area, I want to think about what the area is of one of those triangular faces. Well, each one of those triangles has a base edge that measures 300 and an altitude that's 354. So to find the area of one of those triangles, I'm going to use my formula area equals 1/2 times base times height. And I'm going to plug my base of 300 and my height of 354 right into that formula. I'm going to grab my calculator and I'm going to calculate that area to be 53,100. Now we have not one triangle that makes up the lateral area, but four. So my lateral area is going to be 4 of those congruent isosceles triangles. So I've got 4, each of which measures 53,100 square feet. making our lateral area 212,400 square feet. Now, lateral area, remember, is just made up of those four congruent isosceles triangles. To find the surface area, we're going to have to take the lateral area and include in that the area of our square base. So surface area is going to be lateral area plus the area of one base. Well, our base is a square measuring 300 by 300. So its area is going to be 300 squared, or 90,000 square feet. So our total surface area is going to be the area of our four triangles, the 212,400, plus the area of our square base. And when all is said and done and the mathematical computations are done, we end up with 302,400 square feet for our total surface area. And as you can see, there are a lot of similarities between this and the surface areas and the lateral areas that we've already found. Really, the one big difference here is that we have one base instead of two. All right, the other big difference that we have to think about is the slant height. In the previous example, they gave us the slant height of the pyramid, but sometimes they won't be quite that nice. However, if we know the altitude or the height of the pyramid, and we know the length of one edge of the base, it's a pretty easy process in order to use the Pythagorean theorem to find the slant height of the pyramid. So let's go ahead and take a look at what this might appear like in an example. Like the first problem, we've still got a regular pyramid. In this case, they're giving us the height or the altitude of the pyramid, and they're still giving us the base length of 300 feet. They want us to, though, in this question, find the slant height of the pyramid. So if I go to my picture and label the information that they've given us, they're telling us, number one, that the altitude or the height of the pyramid is 321 feet. Remember that the height of the pyramid is the distance from its vertex down to the center of its base. So there's the height or the altitude of our pyramid at 321 feet. Like the first example, the length of one of our base edges is going to be 300 feet. They want us to find the slant height. Well, in our picture, the slant height here is represented by this dotted or this dashed line. Whether you realize it or not, we do know the distance represented by that red line segment. If the distance from the right side of our pyramid to the left side is 300 feet, this distance is going to be exactly half that, or 150 feet. So now we've got a right triangle where we know that the blue leg is 321 feet, the red leg is 150 feet. It's a very simple process to use the Pythagorean theorem now and go find the slant height or the hypotenuse of our right triangle. So I've got 321 squared plus 150 squared equals our slant height, L squared. And when I type that into my calculator, I find that L squared is equal to 125,541. And then taking the square root of both sides, and I'm going to go ahead and round this number to the nearest tenth because that's what we're asked to do in this problem. We end up with 354.3 feet. Notice that the units here are measured in feet because length is measured in linear units. So 354.3 feet. All right, at this point, if you had questions either about our example 1 or example 2, jot them down in the margin so that you'll remember to ask about them when you come back to class. We're going to go now tackle the last problem for today. This one too, they're giving us a regular pyramid. They're telling us that the height is 8 units, that the base edge length is equal to 12 units, and they want us to find, first of all, the slant height. So I'm going to go ahead and label my pyramid with the information that was provided to us in the problem. So the height is 8 units. The height is going to be the distance from the vertex down to the center of the pyramid. So that green line segment there is 8 units. The base edge length is 12 units. And the very first thing they want us to calculate or to find is the slant height. So the slant height is that dotted piece in that triangle on the right. We're going to do that or find that by utilizing a little Pythagorean theorem action here. If the distance from the right side of my pyramid to the left side of my pyramid is 12 whole units, then that blue line segment will be half that length, or in other words, 6 units. So now I'm set up again where I've got this right triangle and I know the lengths of the two legs are 8 and 6. I can go ahead and plug my 8 and 6 into the Pythagorean theorem. My slant height there is going to be represented by the hypotenuse of that triangle. So 8 squared plus 6 squared, I'm going to take a minute and go plug that into my calculator. So L squared is equal to 100, making the slant height 10. They don't specify here whether this is in inches, centimeters, miles, or whatever, so I'm just going to label that units. All right, so that's the very first part of this question. The next thing they ask us to find is the lateral area. So lateral area, I'm going to think about again, the lateral area is made up of these 4 congruent isosceles triangles. So these 4 triangles that make up our lateral faces, since this base edge length was 12 and this slant height was 10, the base down here is 12 and the slant height in each one of these guys is 10. So it's a fairly easy process to find the area of each one of those triangles. A half times 12 times 10, or 60 square units. So we have 4 of them that each measure 60 square units, making our lateral area 240 square units. All right, so that was a fairly straightforward process. The next part of the question asks us to determine the area of the base. Well, remember that the base is a square that measures 12 units by 12 units. So the area of our base is going to be the 12 times the 12, or 144 square units. The last thing they want us to do is they want us to pull all this together. They want us to find the total surface area. So remember that total surface area will be the lateral area plus the area of our base. Well, above already we found the lateral area to be 240 square units, and we determined that the area of our square base was 144 square units. So put those two together, and you'll find that the total surface area is 384 square units. As always, if you have questions, please write them down in the margins so that you'll remember what they are and you can ask when you come back to class. And the next time that you come back to class, you'll be able to show me what you can do, because we're going to use your newfound skills regarding pyramids to answer some problems regarding pyramids.